we are going to review experimental design, and you should have this packet. Your teacher should have provided this to you, the experimental design packet. It starts with a bunch of terms on the first page, and I got to be honest, I have to kind of look at an example to really get an idea what those terms actually mean. So let's look at an example. So in every experiment, what we're really trying to do is we're trying to show that we have some kind of factor, and we're trying to show that it affects a response. Now, that sounds all well and easy, but of course, there's a lot of issues that come about. That's why we have an entire unit, and there are people that do an entire degree on this issue. So let's just say, for instance, I want to show, does the type of gas that I buy, does that have any effect on the miles per gallon that I get? Okay, so in this kind of experiment, if I'm trying to show the different types of gas, a buddy of mine tells me, hey, if you pay the extra money for the good gas, then you'll wind up getting a lot more mileage and it'll save you money in the long run. Well, of course, I think he's, full of crap, but we'll go ahead and test that anyway. So we need to start off with what are called experimental units. And so in this case, our experimental units would have to be the cars. Okay, so the cars are who's going to get our treatment, the different types of gas, and the cars are where we're going to look at, to see what kind of mileage they got. Okay, so we're going to have units and our factor we've already talked about. Our factor, the type of gas. Okay, the factor is specifically what you're testing in an experiment. Okay, so you also can have a certain number of levels for each factor. So for instance, if you go to the gas pump, you can see like there's 3 different types of gas. Let's just say, for argument's sake, I want to compare the cheap stuff to the really high dollar stuff. Okay, so let's say I want to compare 2 levels in this case, and levels are, in a sense, how many categories we're going to have for the factor. So keep that in mind. I'm just making this one real easy, just so there's no, big concern here. So my treatments are specifically what types of gas am I actually applying. So let's just say, I don't know, let's say I think it's 89 gas. I think it's an octane rating or something like that. Let's say we're going to give 89 gas, and let's say we're going to give the 91 gas. Or maybe it's 87. We'll just say 89 and 91. Okay? So those are going to be my treatments, those octane ratings. Okay? So the response is, in the end of the experiment, what we're actually going to measure to see if my treatments actually had an effect. And so in this case, if I'm going to check miles per gallon, that might be kind of tough to measure perfectly. So I think to make it easy, we'll just fill up the tank and see how many miles we go. So we'll just look at the miles traveled. Okay, so the question from Amanda down there, the level is the specific number of categories within the factor. Now, if you have an experiment that has 2 factors and it has if an experiment has 2 factors and 2 levels, like let's just say, for argument's sake, if I change this up, and let's say I'm not only going to check for type of gas, but let's say I'm also going to check for the type of car. And let's say I'm going to check the different levels, let's say SUV and compact. Okay, now this factor has two levels. This factor has two levels. So when we look at treatments, treatments is the specific application to the unit. So for instance, this experiment, this modified experiment, would have 4 treatments because we give it the 89 gas and an SUV. We give the 91 gas and an SUV. We give it, and you get the point from here, right? Okay, so hopefully that addresses that question. But let's just keep it simple here. Let's just make it one factor, this type of gas, okay? Now, so there's 3 principles in experimental design. We call them the principles of good design. And every good experiment has to use those principles of design. The first one is pretty obvious. The first one says, well, I mean, just act, if we took cars, and let's say I just take my car and I fill it up and I drive on the 89 gas for a full tank, and then I drive on the 91 gas on a full tank, and then I find out that my car did better on the 91 gas. Well, I mean, that's kind of stupid, right? Because that clearly doesn't show that the 91 gas is getting better mileage. In fact, it could be all sorts of factors. So the first principle is what we call replication. Okay? And replication simply means having multiple units for each treatment. Multiple units for each treatment. Now, obviously, the more units, the better, because then we kind of account for variability. Okay, so let's say we're going to design this experiment, and we're not just going to use my car, but let's say we're going to use 50 cars. Okay, that's called replication, because now these treatments are getting more than one unit. So we can see how they act under different conditions. Okay? All right. So I must say what is already weird is not hearing my students talking and answering questions, but I'll try and get adjusted to that. So here's kind of the issue in an experiment. Is the type of gas the only thing that affects your mileage? And I don't know if y'all can access the chat screen down there. Can anybody type in something real quick that might also have some kind of effect on the mileage? Type of car, I saw that from Monet. Type of car, love that. I saw tire size from Jackson. Love, oh, if I can spell. Tire size, love that. What else? Ooh, wind speed from Tyler, love that. Wind speed. Okay, and what do I got? Ooh, the way you drive. So let's say the driver will affect the road. Whoops, not rod, the road. Okay, so here's the deal. City versus highway. I love that. City, highway. Bottom line is, there's a lot of stuff out there that can affect mileage. These other variables that undoubtedly occur in an experiment are what we call extraneous variables. So what's an extraneous variable? If we define it real quick, an extraneous variable is a variable that affects the response. And every experiment has them. I mean, every experiment, no matter how good we try, are going to have extraneous variables. I mean, y'all just came up with a bunch right there pretty easily, okay? So the question is, how do we account for all of these extraneous variables? Well, one thing we can do is, let's say someone mentioned road. Well, what we could do is say, I think that if you're on a country road, it might be different than if you were traveling down the interstate. Well, okay, we're going to account for that, and we're going to have all the cars travel on the exact same road. So what have I just done in that experiment? Well, it's the second principle of design. Taking one of these variables and modifying our experiment to account for those is what we, Monet, love you. Look at that, control. It's called control, folks, right? Okay? Control is adjusting the experiment to account for extraneous variables. And I almost don't like that I say account. I should say to reduce the effect of extraneous variables. I mean, that's kind of the goal. So, I mean, if we look at these, we can control for a lot of these, right? I mean, we can control for driver. We can make the same driver do the experiment every time. We can control for the type of car. We can make sure it's the same car. We can make sure the tires are all the same. Wind is a little harder. I mean, we could try and make sure we go at the same time of day in hopes that that would control. City versus highway, we can kind of control for a lot of that, okay? But the problem is, let's say just for instance, that I'm going to run this experiment and I don't want to do all the driving myself. I mean, the driver is going to get ridiculous if I have to go out there and drive, let's say, 25 times on a full tank of this and 25 times on this. I mean, that's getting ridiculous. So instead of controlling for this, what I can do is the third principle of design, which is called randomization. And in randomization, we are randomly assigning, I think I misspelled that, assigning units to treatments. That's randomization, right? Randomly assigning a unit to a treatment. I tell my students, we diagram this stuff. So if I diagram this experiment real quick, I've got my cars, and I'm going to assign them to the 89 gas and the 91 gas. And the key is, I do this in a random way. Okay, and then I can compare that miles per gallon. Okay, so here's the deal. Randomly assigning here, let's say I do have a bunch of different drivers. Well, as long as the same driver is not doing the 89 gas, as long as we randomize all my drivers, then one driver will not be applying all these treatments. And so then we don't get issues of these variables possibly affecting miles per gallon. Like someone said, wind speed. Well, if we can't adjust for wind speed by randomly assigning these treatments, we assume that, sometimes we run the experiment under 89 gas, it might be real windy. And sometimes we run it under 91 gas, it might be windy too. But that's going to kind of even out those effects. Okay? So that's kind of a quick little overview of the 3 principles of good design. Okay? Just a little overview real quick. But you may have heard the term, not extraneous, but you may have heard the term confounding. What makes a variable confounding? Well, I'm going to take one of these, and I'm going to take type of car, okay? So if I take my cars, okay, and let's say I have all the SUVs use 89 gas, and I have all the compact cars do 91 gas. And then we're going to compare the miles per gallon. Oh boy, now we got an issue. Okay? Now we got a big issue. And the issue is, am I really going to be able to tell that the gas is what's getting less miles, or is it the fact that these were all SUVs? So this makes that extraneous variable, the one that we talked about, type of car, that makes it confounding. Okay? And so if you want a definition on that, a confounding variable is an extraneous variable it's one of these guys can become confounding if the variable varies with the levels of the factor. So it's an extraneous variable that varies with the levels of the factor. And so what happens is, when we're done doing the experiment, confounding variables make it virtually impossible for us to tell if our treatment is affecting our response or if it's that confounding variable. So obviously this is a bad idea, right? We don't want to do this because I'm not really getting the results I want. Now, I should point out, in this experiment, is the type of car confounding? And this is really weird because I'm waiting on responses, but I mean, well, the answer is no, it's not confounding anymore, because are all SUVs, if I randomly assign, are all SUVs going to be giving the 89 gas? No, we're going to have a mixture of those cars getting the 89 gas, and now I've evened out those effects. Okay? So that's why randomization is a powerful way of taking care of these confounding variables. Okay? Now, one other thing before we start getting into some problems. What's a way to improve on this design? A way to, oh my word, look at that. Monet and Tyler. People are going to think I'm texting you answers there. Absolutely perfect. Blocking, first of all, you have to pick a variable that you know might be confounding. Okay? I mean, for instance, does whether the driver wears makeup, I mean, that has no effect at all. I mean, that'd be stupid, right? The race of the driver, I mean, that's stupid, right? Whether it's night or day, well, I mean, you might argue that might have an effect, okay? So, bottom line, to fix this and improve on it, we can take those cars and take all those SUVs and those compacts, and now we can randomly assign the treatments, the 89, the 91, to both groups. And so what does blocking really do? Well, Blocking takes this group and reduces the variability. Courtney, perfect. Reduces the variability, right? Because now, if SUVs are really crappy when it comes to mileage, then aren't all these cars in this group going to all have crappy mileage? And all the cars in this group are going to all have better mileage. The only reason we ever block is to reduce variability. So you got to choose a variable that makes sense. Okay? So, anyway, that's a quick overview of what I spend about 4 weeks in class doing. But let's get into a problem in your packet. And I apologize. I don't know why it's looking so... I don't know if y'all can read it on my screen. I'll try and get it to come up a little better. All right. So, it's 2006B number 5. If y'all will look that up, okay? It's the tractor pulling a plow through a field. So it says, when a tractor pulls a plow through an agricultural field, the energy needed to pull the plow is called the draft. The draft is affected by environmental conditions such as soil type, terrain, and moisture. A study was conducted to determine whether a newly developed hitch would be able to reduce draft compared to the standard hitch. And they tell you, just in case, you don't have that problem, a hitch is used to connect the plow to the tractor. Okay? So 2 large plots of land were used in this study. It was randomly determined which plot was to be plowed using the standard hitch. As the tractor plowed that plot, a measurement device on the tractor automatically recorded the draft at 25 randomly selected points. And after that was plowed, the hitch was changed from the standard to the new one, and it says that's a process that takes a substantial amount of time. And then they use the second plot on the new hitch. Now, I gotta be honest, when it comes to the AP exam, I'm a big proponent when it's an experimental design question. I am a very visual person. So my first thought is, before I even try and tackle this problem, I don't know what just happened. I apparently hit a button. All right, act like that's not there. Now it looks worse. Okay, we're gonna... I don't know if you can see that at all. Wow. Okay. Give me 1 second. Natalie, the packet, it should have been given to you by your teacher. If you don't have it, it's okay. I don't know if you can read. I'm trying to get this to come up a little clearer. Maybe that's a little better. There, maybe that'll work. Maybe that's a little better. Okay, all right. So here's the deal. What I encourage you to do is, when you're given a problem on experimental design, the first thing I would do is go ahead and draw the actual experiment. Just a quick little sketch, just so you know what's kind of going on. So the units in this experiment are the plots of land. Okay? And we know that because the plots of land are getting our treatment. They're being plowed with this hitch. Okay? And then we are assigning those plots of land to either a standard hitch, I believe they call it, a standard hitch, and some new hitch that they created. And we are comparing the draft. Okay? Now, again, the draft is the response variable here because in the end of the experiment, what are they trying to measure to see if my treatment's working? Well, they're measuring the draft, okay? So the question is, did they randomly assign the plots of land? Let's see if we can examine that real quick. And if you look carefully, you will notice it says right here, it was randomly determined which plot was going to be plowed with the standard hitch. And then the other hitch was applied to the other land. So this was randomly done. Now, I think it's worth the 2 minutes it may take to sketch out the design so that then you can answer the questions pretty easily from this point, okay? And the reason I say that is this gives you an overview, a picture of what all these words tell us. And I don't want to have to go back and reread that every single time. Now, I might to get some detail, but I really think the picture helps. Because now, what's the response variable? Well, the response is the draft. The treatments, well, we labeled those up here. It's the standard hitch and the new hitch. And the units are my plots of land. So, all that straight off my picture, okay? So, let's go to letter B. Given that the goal of the study is to determine whether a newly developed hitch reduces draft compared to the standard hitch, was randomization used properly? Now, here's a temptation of students is we know what randomization means. I mean, we talked about it earlier. Randomization is randomly assigning units to treatments. Well, so it might be tempting to say randomization was used, and we might want to answer this as yes, since they randomly assigned, and Amanda, I'll get to that in 1 second. Since they randomly assigned units to treatments. Well, if I can ever put a big red flag, there's my beautiful red flag. If I can ever put a red flag on anything, it's this right here. On the AP exam, what makes students lose tons of points on the open response is this right here. Context. This gets you no points. It's a perfect definition, okay? That is a definition of randomization, okay? But the context means, have you told me what this means in terms of the problem? Well, that means instead of saying they randomly assigned units to treatments, what should we have said on this one? They randomly assigned, now fill in my context. They randomly assigned, who are the units? We said plots of land. So they randomly assigned plots of land to, again, who are my treatments? The standard and new hitch. So they randomly assigned plots of land to the type of hitch. And that was given us in the problem. Okay, that wasn't even a question. Now, Amanda, your point of there being only 2 plots of land, there are only 2 plots of land, and obviously that's not a good experiment. I mean, it's a terrible design, but it does apply randomization. They randomly assigned those two plots to the hitches. Now, what is the issue that Amanda's bringing up? The fact that there's only two plots of land means how many plots of land are being assigned to this hitch? One. How many plots of land are being assigned to this hitch? One. Okay, so can someone type it fast? What's the issue that Amanda brings up? They did use randomization, but they did not use, I'm waiting for the first one. They did not use replication. There we go. Ooh, I got about 3 or 4 right there. Okay. And you'll notice Amanda right down here in letter C, that's the next question. Okay. You'll notice they ask in the next question, they said, was replication used? So they already knew that was an issue. Okay. So how are we going to answer letter C? Again, we've got to put context on this. Okay. So if we're answering, was replication used properly, we say no, since, now think context here. In terms of this problem, it's no, since each hitch was only assigned one plot of land. Okay? Now, by the way, students often think on the AP exam that you have to write like a novel on your answers. You don't have to write a novel. You just have to answer the question. Okay? And I'll tell you right now, the most important thing in answering the questions is right here, folks. Context. Okay? Red flag. Context. Do not forget it. All right, let's go to the last part here. So if I jump down here to letter D, it tells me that plot of land is a confounding variable. Okay, I know I have not found a way to get this to look any clearer, but I hope y'all can read that well enough. It says plot of land is a confounding variable. Now, let's think about why, again, this is why I draw the picture. Why is plot of land confounding? Well, ooh, Madison, I like location. Terrain, I like terrain. Any other thoughts? Sorry if you're on a phone, it's a little harder to, I think, chat on this. Proximity to water, nitrogen levels, these are all great. And by the way, they actually gave you the answer up here. They said it was soil type, terrain, and moisture. I mean, they don't expect you to be farmers. They don't expect you to know all this. So they kind of give you the answer in the problem. Okay? So here's the deal. I'm pretty impressed with William's answer too. Nitrogen levels. But here's the deal. So why is plot of land confounding? Well, since I have messed this camera up. Okay. Since different plots of land can have various soil type, terrain, and moisture, which will affect the draft. Now, we, oh, Issa, that's a great idea. If any of you are having problems with not having the packet, Issa brought up a great point here. You can go into Google, and generally you can type in AP statistics, open response, and then type in the question I'm on, and it'll pull up. We're about to wrap this one up, and I'll tell you when we get to the next one what question it is. Now, here's the deal. On the AP exam, this is what a lot of students said. Unfortunately, this only got me a P. It only got me a partially correct response. Okay? It only got me a partial. The reason is all that I argued right here was that plot of land was not confounding. What did I argue here? I argued that plot of land was extraneous. Remember, there's all sorts of stuff that can affect the response. That's all that I argued here, is that the different plots of land can have all these different features which affect the response. So how do I bump this up to get that E, that essentially correct? Well, I've got to argue that it's more than just extraneous, it is confounding, so therefore we will be unable to tell if the hitch reduced draft or the plot of land. And that a lot of students messed up on right there. That statement right there. This is arguing that it's confounding. That's my argument, that it's confounding. Up here, all you argued, I ran out of colors here. All you argued up here, right here, was that it was extraneous. Okay? So you've got to remember, this whole session is really about the terms. You got to remember, you did get points now if you explain this answer, but you've got to go that extra step and tell them that it's not just extraneous, but because we're getting this kind of deal where we're getting these random, but plot 1 is here and plot 2 is here, because this is happening, I'm unable to tell if the hitch reduces draft or the plot of land. So that's one of my favorite problems. I love that problem. All right, so let's go to one that's a little more, here's another good one, okay? So let's go to 2007, and if you don't have the packet, you can pull this problem up real quick. If you'll go to 2007, and it is problem number 2. Okay, it's problem number 2 in 2007. Again, if you Google that, it should come up pretty easily. Okay? So, let me, I think I'll go ahead and read it in case y'all can't see my copy here. All right, let me get some water first. All right, so it says, as dogs age, diminished joint and hip health may lead to joint pain and thus reduce a dog's activity level. Such a reduction in activity can lead to other health concerns such as weight gain and lethargy due to lack of exercise. A study is to be conducted to see which of 2 dietary supplements, glucosamine or chondroitin, is more effective in promoting joint and hip health reducing the onset of canine osteoarthritis. Researchers will randomly select a total of 300 dogs. Whoa, that looks really blurry. From 10 different large veterinary practices around the country. All the dogs are more than 6 years old, and their owners have given consent to participate in the study. Changes in joint and hip health, nope, that's worse, okay, will be evaluated after 6 months of treatment. Thank you, Melissa, for posting that up there for us. I appreciate that. All right. So, let me see how good y'all are at typing here. I'm going to ask you instead of just give you the answer here. Let's draw the picture. Okay? Now again, I'm not really getting any points for drawing the picture, but I'm visual. I have to see what I'm doing here. Who are the units? And I'm waiting for an answer. Who are the units? Dogs. We got it. Yep, that's pretty much it. So we got dogs. Okay. All right. What are the treatments we're giving them? I guess we should hum Jeopardy instead. All right, dietary supplements is right. Let's be more specific. Which ones? There we go, William. You got it right there. It's given up here. Those are my 2 supplements, okay? So, we are giving them glucosamine, and chondroitin. I think that's how you say it. By the way, did it say that they randomly assigned this? Does it say that they randomly assigned? Let's see, it's conducted, it's to prevent joint health. It says they randomly selected a total of 300 dogs. It doesn't really say that they randomly assigned the treatment, though, did they? They randomly selected the dogs, okay? Oh, did y'all catch that point from Miss Moffat? She just emailed the copy of the notes. Thank you, Miss Moffat. Y'all have an awesome teacher out there in Greenbrier. A shout out for Miss Moffat. So here's the deal. Yeah, we can't really assume, Ingrid, you're right. So the deal is, what are we comparing in the end, though? We're comparing, let's see, what are we trying to, I think it says joint and hip health. Joint, hip health. And I guess the onset of canine osteoarthritis. Okay? Now, again, that's not really helping me, except it gives me a visual. Okay? And I like to see the visual. I think it's worth the 1-2 minutes or whatever that it takes. All right, so now let's go to letter A. Okay? What is an advantage to adding a control? Now, here's the deal. What they're saying is, what is the advantage of adding another group that's called a control group? Now, well, here's the deal. If we didn't have a control group, all we can tell is if glucosamine is better than chondroitin, or if chondroitin is better than glucosamine. Well, what if neither of these are actually, Monet, you already, my word, Monet and Courtney, you stole the words right out of my mouth. What if these don't work at all? I mean, adding a control helps us to see if these supplements actually do anything at all. I mean, maybe they don't help at all. So how do we answer that on the AP test? How do we need to say it? Remembering that we have to give context. So I would say in part A control group allows us to have a comparison to see if either treatment works at all. Now, you could probably say that a lot better, but that's the goal. And oh my word, I kind of messed that up already. How did I mess that up already? Where's my problem here? Just to be safe, I better add some context. Thank you. Again, if you learn nothing at all in the hour that we do this, if you learn nothing at all, I want you to learn context. So how can I fix this? To see if either glucosamine or chondroitin work at all. That's a better answer, because now I've got context, okay? All right, let's jump down here to letter B, okay? And in letter B, it says, assuming a control group is added to the other two groups in the study, so assuming this happens, explain how you would assign those 300 dogs to the three groups for a completely randomized design. Now, I don't know how every teacher tends to explain this one, but I think a lot of teachers prefer the old, well, that's terrible, the old pull them out of a hat, right? Hat method. Thank you, Melissa. You got it. Okay. Now, I'm not going to write all that down. I think y'all pretty much, I think you pretty much know how to do that. I love what Tyler said. Put each dog into the hat and pull out 100 for each treatment. That is accepted on the AP exam, even though it's not, maybe physically possible. It's a random assignment. Now, what I would say is, Tyler, we want to make sure we put enough detail on that. So I'd want to say, I put the 300 dogs, I like that, Monet. I put the 300 dogs into the hat. I shake the hat around, randomly pull out 100 dogs. Those first 100 receive glucosamine. Do you see what I mean? Tyler, your answer, I understand what you're saying, but the scoring standard always says it has to be enough detail for someone who's basically mildly competent to be able to repeat it. So you want to say, the first 100 I pull out receive glucosamine. The next 100 I pull out receive chondroitin. And the last 100 receive the control. Okay? Now, I'm not going to write all that down. I think we're all pretty good with the hat method. Okay? So, the only reason I shy students away from the whole random number generator is, random number table, is you tend to leave out some detail, and the graders will get you all the time for that. So it's a little easier to just use that, pulling them out of a hat. Let's go to letter C real quick. Rather than using a completely randomized design, so they're scrapping this idea. Again, you see where the picture helps? When you have the picture here, you can always go back to the picture instead of going back to all the words, which we kind of get lost in. Okay? All right. So rather than using a completely randomized design, one group of researchers proposes blocking on clinics, and another group proposes blocking on breed of dog. How would you decide which one's a better blocking? Okay, so the question is it better to do, let's see if I can move this camera up here. All right, is it better to do the, what did they say, clinic breed of dog. Which one makes a better confounding variable? Okay. Any other thoughts? I'm seeing breed a lot. Okay. And you're absolutely right. Remember the idea for confounding. For a confounding, for in a block design. Remember when you design a block, let me go back to my car problem, okay? What was the whole goal in designing these blocks? To reduce variability. That's the goal. So the only way you're going to reduce variability is if this affects the response. So the question is really, which one of these do you feel really affects the response more? Okay? Do you think the clinic has a bigger effect or the breed of dog? I would definitely say the breed of dog. So I would say breed of dog, and now let's argue why. Since different breeds can have different joint hip health and the breed seems to have more of an effect on joint hip health than the type of, or the clinic. So that's the key. If you're going to pick a good confounding variable, it had better affect the response. So the question they asked is, which one seems to affect it more? I mean, well, I think breed of dog definitely has more of an effect than what clinic they go to. Because clinics, we assume, are going to get a random sample kind of dogs. I mean, I don't think there's many clinics out there that only accept German Shepherds or something like that. Okay? Now, I'm seeing other things like age of dog and dog size. Those are great. Okay? Those are also, I would say, great blocking schemes. And they might actually do better than breed of dog. But again, in the question, we got to be careful here. In the question, they only asked us to compare those two, and they only asked us to decide which one of those two was actually better. But those are great ideas. Nathan, that age of dog would definitely, you know, a 6-year-old dog versus a 10-year-old dog. Big effect. I think it's Issa, I'm guessing. I hope I'm saying that right. The dog size definitely has an effect. So, slide paper up. I'm sorry, Monet. All right. So, there are tons of questions on experimental design. I can basically say this. There are plenty of them left for your teacher to look at with you when they start reviewing for the AP exam. If they're like me, they're still trying to finish the course. But there's tons of them out there. I hope that the little review that we've done, kind of going over the terminology, I hope that has helped. I will honestly say these are questions they have really liked asking lately on the exam, either sampling or experimental design. These are great questions because there's no math, guys. There's no math It's all about just knowing the terminology. Just to address your question, we can look at them. There's only 3 that are actually in the packet. And if you want, Issa, when we log off here in a second, when we shut down, we're going to have a 20-minute question and answer session. I can show you some of those multiple choice that are in the packet. We can go over those. I'll be honest, Issa, they tend to hit experimental design and sampling very basic in multiple choice. Open response, they really get into the detail. So I'm getting, Cardi said it was a requirement to have evidence of the multiple choice. Okay, well, we'll go over it here in a second. So I'm going to say that if you have no questions, you may feel free at this time to log off and have a wonderful night. For those of you that still have some questions, and I believe, Issa, you had a question on those at multiple choice, we're going to stay on for a few minutes, and we'll try and hit those questions. Tyler, I will hit that question here in a second. Everyone else, if you have no questions, y'all have a wonderful night. Let's start off. I'm hoping I'm getting the right person here. Was it Issa? You asked about multiple choice. Issa. All right, there's 3 on the packet, and we can kind of look at those real quick. Okay? So I appreciate the comments, guys. Thank you so much. This was a little weird not having students in front of me, but hopefully this was beneficial. So Issa, I don't know if you can see that well enough. Let me get this paperwork off here. Thank you for that, Monet. That's called a fashion statement. All right. So let's look. All right. Which of the following is a key distinction? Now the problem is, Issa, if you don't have the packet, I don't know what year this is from. So bear with me. But we can still look at them here. I'll read it to you real quick and we can kind of go over it. So it says, which of the following is a key distinction between a well-designed experiment and an observational study? More subjects are available for experiments than studies. Well, I mean, that seems kind of pointless, right? I mean, in fact, I'd probably argue the other way around. It's easier to get people for a study than it is an experiment, where you might give them a drug or shoot them up with who knows what. Letter B, it says ethical constraints prevent large-scale observational studies. I mean, I don't see any reason why ethics would have anything to do with a large-scale study. Now, experiments, letter C, experiments are less costly to conduct. Well, I mean, that kind of depends. It depends on the experiment, so I don't think that's either a good answer either. Letter D, though, says an experiment can show a direct cause and effect relationship, whereas an observational study cannot. That is our answer right there. That's it. Because if you remember, what did we do when we designed this experiment? All these variables we were worried about, we either controlled for them or we randomized to make sure that we took those variables kind of out, evened out their effects, okay? So that's the question. That's the key. An experiment shows cause and effect. That's the big key, okay? So cause and effect. All right. Let's go to number 2 real quick. We can look at that one. It says, this is a study of existing records of 27,000 automobile accidents involving children in Michigan found that about 10% of children who were wearing a seatbelt were injured, and that about 15% of children who were not wearing a seatbelt were injured. Wow, big difference. So we have 10% who were wearing a seatbelt injured, 15% not wearing a seatbelt were injured. Which of the following statements should not, now there's the key, not be included in a summary of the report? So Issa, you said D. D is absolutely correct, and it kind of goes back to what we just talked about. Does this study clearly demonstrate that seatbelts save injury? Well, no, because all we did was we looked at the data, but we have nothing, we've done nothing to account for all those other variables. Okay? That's what a good experiment does. It accounts for all those variables. Okay? All right, and let's try 3 real quick. I can scoot down here. All right. So it says, a new medication has been developed to treat sleep onset insomnia, a difficulty in falling asleep. And by the way, Tyler, I don't know if you're still on, but I'm going to get to your question in a second. Yeah, I think you're still on. Okay? Y'all tell me what you think on 3. New medication. Researchers want to compare the drug that has been used in the past to compare the length of fall asleep. Which is the best method for obtaining this information? And so, I mean, we know we're going to randomly assign the subjects to groups. Why? I mean, I'd say it's either D or E. Okay? Now let's see if we can figure out why. Giving new drug to one group and no drug to the other group and then comparing the results. Is that really designing the experiment to test if, as what they said right here, compare this drug to a drug that has been used in the past? Well, no. So clearly the answer here is E. Okay? And Issa, I must admit that those are the only multiple choice that are in the packet. If you have a prep book for the AP exam, they might have some more of those. I gotta be honest, they don't tend to get too tricky on the multiple choice, on experimental design, especially. They kind of stick with the basics there. Okay. Now, Tyler, you had asked a question, and I'm trying to find. Aha. Tyler asked a question about one of these words on here. I believe that's what you asked about, Tyler. Scope of inference. All right. Thank you, Tyler. All right. So, scope of inference. Let me just explain what it means real quick. Let's go back to my car example. I hate to keep going back to the same example, but what if the only cars that I used were trucks? All that I used was trucks. Maybe I compared like the F-150. I had some F-150s. I had some Tacomas, all sorts of different trucks. Okay? Now, if all that I used is trucks, and I show that the 91 gas actually does better, can I say that 91 gas will do better for a compact? Well, and the answer is no. Okay? So what we call that is our scope of inference. If your experiment is only on trucks, the only thing that we can conclude in the end of our experiment is that the gas will give you better mileage for trucks. Okay, go to the, where am I at? Do you remember the problem on the chondroitin with the dog? This problem. Tyler, if I only used this, let's say the only dogs I had available were German Shepherds. Okay? If glucosamine winds up being the best drug for my German Shepherds, can I say that it's going to behave the same way for poodles? And the answer is no. Okay? That's called your scope of inference. You can only infer when you're done with your experiment within a certain, quote, scope. And that scope depends on who your units were. Okay? So, Tyler, I hope that answered that question.